So problem 1. If I have n equals 20, x equals 5, p equals 0.3, and then I'm asked to use the binomial probability distribution formula to find p of x. I wrote the formula up above, so I'm looking for p of my x is 5, so I'm going to put 5 there. Remember, that means the probability of 5 successes. And then I will fill in. I have n, which is 20, choose x, which is 5, so that's 20, choose 5, and then I have p to the x, and my p is 0.3, x is 5, so I'm just going to put the 5 up as the exponent, and then q to the n minus x. Now I don't have q, it wasn't given to me, but remember q is going to be 1 minus p, so whatever p was, I'll plug that in. 1 minus 0.3, that's what I have in my setup as my p, so I subtract those and I get 0.7. So q is 0.7. So put in here q, 0.7, and then to the n minus x. So my n is the 20 minus x, which is 5. And now the next thing I can do is just subtract 20 minus 5, and I get 15, so I'll just write that up above. Now when I'm plugging things in on my calculator, I want to do the one with the large exponent last, because that's the one I want to leave sitting on my calculator. So I'll purposely do things in the other order if necessary, so that that's the calculation I do last. The other ones I'm going to write down. My first calculation is 20, choose 5. Remember, that's not 20 divided by 5 or 4. It's 20, choose 5. So I type in on my calculator 20. On this calculator, I have to push the PRB button and scroll over with my arrow key to get the N choose R, and then I push enter. So now it says 20 and choose R, and then I want 5 next. So there's my 5, and it comes to 15,504. So I'm going to write that in. P of 5 equals 15,504, and then I want to put in the 0.3 to the 5th. So on my calculator, 0.3, my to the button for this calculator is the caret. Remember, yours might be y to the x. So to the 5th, I get 0.00243. I'm just going to record that. And then my final calculation for this is 0.7 to the 15th. And I expect that to be a lot of decimals, so I'll type it in and see 0.7 to the 15th equals, and there I do have quite a few. I'm just going to record a couple of them just so that you can see where 4, 7, and then I put dot, 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 so you can see what my calculations were there. Slide this over just a bit. Q equals 0.7. Now I have this number sitting on my calculator, the 0.0047 on and on. I need to multiply by this number, so I'll say times, and then 0.00243, enter. That's the product of these two here, and then I need to do one more multiplication, so times again, and this last number, the 15,504, enter, and there's my result. So P of 5, remember that's just notation, I'm just going to record it all the way down to my answer, equals 0.17886, and I want to record 4 decimal points of accuracy. I'm looking at that one, the 8, and I'll analyze the next number following, and it's 5 or greater, so I do have to bump up the 8. So my result will be 1789. That's P of 5 equals 1.1789. Now what I could also say that is the probability of 5 successes is 0.1789. I could also say that as a likelihood, a percent likelihood, and I could say 17.89% likely. So I could say 5 successes out of 20 trials, that's my N, out of 20 trials is 17.89% likely. So I could say that two ways. This one was stated with probabilities as decimals, so I'll state my solution with decimals as well.